Hello, hello. This is a new electric show. For the entrance, let's play some. Okay, this is the educational video for the for explanation how speaker works. How speaker work? It's quite simple and yet it's quite complicated. It's like this. Let me zoom out a little bit. Okay. This is like a side view of the speaker, and this is the coil, which is located here. By here I mean here. Let me do like this. Okay, the coil is located inside the magnet. So inside here is the hollow. Basically there is nothing, and inside is coil. If we look like this, the coil inside the magnet is attached to this piece which we call diaphragm. Okay, the magnetic field inside are conflicting by the passing. I can do like this. Okay. So when the electricity passes through this coil, it produces a magnetic field which is in conflict with this magnetic field here and here. You can look like this magnetic field here, and inside is a coil, and this coil is in conflict with this magnetic field around it. So let's go to the next picture. Okay, yes. So the coil, yeah, let me try something different. Okay, let's try like this. Nah. Not so good, and yet it's functioning. Okay, the magnets and the magnet and the coil, and this is another picture of speaker. So the magnetic field is pushing this coil to go up and down and up and down and up and down and up and down through Hi-Fi or some other source. We give some electricity to this conduit, which is connected on the speaker membrane. Let's say here and here. So the voltages different, how we call it, the potential between these wires is different, so we have voltage across these two wires. So the voltage basically equal some current passing through this coil, and it's creating a magnetic field. So magnetic field oppose or attract by this natural law, attracting or repelling. We have movement of this coil, which is attached to the some piece of cardboard, a rounded piece of cardboard. So let's go to the next picture. Oh yeah, more of this same stuff. But basically the coil, the magnets, which are attached to the coil is attached to the membrane. The membrane is attached through the spider, they call it spider, flexible part of the membrane, like this, to the housing. And yes, the flexible part is connected to the housing, and this membrane go up and down and up and down and up and down through this magnetic field. What else to say? We have in creation some little bit some detailed version of this, but basically coil, magnets, some electricity passing, let's say amplitudes, some sinusoidal how you call it, sinusoidal signal is passing through this coil, and it's making the coil move because the magnetic field around the coil is opposing to the magnetic field created into the coil part. So the basically coil is moving up and down because the sinusoidal signal, or the way we talk. What's next? Yeah, you can the power of the basic, how much current can pass through this and how much power can produce. By the power I mean equal momentum of this diaphragm. So you can move like this, or you can move like this, depending on the frequency and depending on the current which is passing through this coil. Yeah, that's it. Okay, let's go on practical. In the meantime, okay, let's play my music. Okay. Get ready, it's about to explode. The sound of fire is a heavy load. In the shadows we come alive. With the pieces all ready to ride. Feel the currents running through our veins. A lightning striking, breaking our chains. Electric So what we can see here, okay, here we have different kind of speakers. Let me take some tools. Yes. We have rounded speakers. Oh yeah, you cannot see this. Oval speakers, rounded speakers, rounded, but basically, maybe you can see here what I was talking about. So in the middle, the coil, just here. In the middle, the coil is connected to this membrane. In this case, this is a plastic membrane. Coil is connected to this membrane, and the coil is going in the middle of the magnet. And when some current passing through this some electricity / current passing through these contacts, it's passing through this coil, going through the coil, creating currents / creating a magnetic field, which is making this making this membrane to vibrate on some frequencies. This is a different kind of speaker. Okay, what we can see, not much. Different kind of speaker. This is like for the bass speaker. You can see membrane going up and down. This we would say it's a normal kind of speaker. You see the wires. Let me try to. So this is connection point, and the wires are going. Let's see. Okay. The wires are, let's say, welded, glued on this membrane, and you can see it here. Here, from the outside, going glued. From the outside, they are passing through the membrane. They are glued on the membrane. They're glued to the membrane and going in the middle of circumference. And the middle circumference is a small circumference where is the winding. Yeah. Okay. So that's this speaker. Yeah. So also this speaker, the membrane. Oh, some wires. Okay. But basically the construction is very similar or same. Until you want some different kind of sound, different kind of frequency to project on on this speaker slash membrane, then you need to make different kind of, or this is like we want the speaker but not too big speaker because we don't have space. So let's make this kind of speaker. This is television speaker. The same stuff, basically the same stuff inside. Yeah, this is kind of television speaker, which is the same. But as you can see, it doesn't move that much. The membrane, it doesn't move. So yeah, this, see, this part is membrane and this part is so-called spider, because spider is attached to this casing. But yeah, it's like this. And this is interesting kind of speaker, because piezo, it's piezo. Oopsie. Okay. This is, I would say, some kind of color. You see, this is one, like color, and then this is one, and then this is like crystal, and this is like membrane, this metal. So the current, you see, passing or electricity is connected here, and the current is deforming. See, this is like, let's say, plus and minus. So the current is passing through these two layers. This is like sandwich. This passing these these two layers, and in the middle is a crystal which is deforming by passing of electricity. So I don't know if I can make better view, but yeah, it's interesting. So we have introduction by theory. We have introduction by practice. Now let's go to make practical demonstration. In the meanwhile, oh yes, I'm back. I have something more to show you. Yes, more interesting. So if you take a part of the speaker, you can see the membrane. Okay, you can see the membrane. Come on. Okay, you can see the membrane. This is a connection which is passing from the outside, as you can see, and going here into this coil, which looks like this. So basically this is like this. Now let's make, yes, yeah, that's it. So the coil is around this. Okay, let's, so the coil is around this. I don't know how do you say it in English, tube, yeah? Cardboard tube, and is forcing this cardboard tube inside this hole. So the cardboard tube go inside this hole, and magnetic field is pushing up and down this. This like this. We have another demonstrative example. This is a speaker which is open up even more. So this speaker is working, so I will demonstrate it, but basically same stuff. Same stuff. You see the coil inside. Yeah, the coil inside, and this is just protection for the dust. This is a membrane. Oh yeah, subscribe and like. Yeah, this is the membrane, and this piece is the spider. Okie dokie. Let's make some magic, huh? Okay, I will connect this, and let's see what will happen. I have my idea. This is not sponsored video by anybody. So basically I use these tools. This is function generator. This is function generator. What to say? We have sine 100 hertz. Oh no! We will make 1 hertz. 1 hertz. Okie dokie. And this is connected, as you can see. As you can see, that's this. So red and black. These wires are going. Can we show a little bit more? I don't know. Oh, yes. So these wires are going in. As you can see, here and here, and going down by the tubing. So you can see the speaker is not in a good shape. And what we'll do next is doopsie. Oh. We will push this to 1 hertz. Ooh. Interesting. We have sounds. What is happening here? Okay. Let's see more. Wave, sound wave. Okay. Yeah. We have modified to 5 kilohertz. 5 kilohertz. One microhertz, 1 hertz. And let's see, will it work? Yes. So, okay, less than 1 hertz. We have, I think, 1 millihertz. Okay, let's see, will it make some? 1 millihertz, 2 millihertz. Maybe more light, I don't know. See this? Oops. This is 1 hertz. Actually 3 millihertz, but see, magnetic field is moving the coil. Okay. Let's go to 1 hertz. This is 1 hertz. One moment to make it more stable. See, it's like magic. So we have 1 hertz, peak to peak 30 volts. So basically like 6 volts peak, 6 volts plus 6 more volts minus. This is like magic. See, this is what, 2 hertz. Magic. So let's go up. Six hertz. I don't know why this is like why we have this kind of signal. Stop post to depth. Stop post to depth. Okay. Aha. Sad bi moglo biti pravi sinusoidalni. Ok. Aha, to je mode bio, aha. Ok. Ajmo povećati frekvenciju. Evo ga. Znači ovo je 1 Hz. Fokus. Sedam Hz. Osam. 10 Hz. Malo ispada ko mali motorin. English, yeah, it's like a small motor, huh? Yeah. Yes, it's like a small motor. By 1 Hz. No, this is like 12 Hz, 13 Hz. And we are speeding up. We are pushing. Twenty Hz, 20 Hz. Thirty Hz. Oh, self-balancing, huh? Check this, huh? Cool. 30 hertz. Let's go down again. Oh. 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 30 hertz. You can feel or hear the frequency. Forty hertz. Pushing. 50 hertz. Still alive. 50 hertz. Check this out, huh? Yeah. Funny, I don't know. For me it's funny. Speaker, huh? 50 hertz, huh? Let's go up. 60 hertz, still alive. Check this, huh? It's a machine. It's a F machine, huh? 70 hertz, still alive, huh? It's funny. Ooh, god damn. 90 hertz. Check this out. This piece of speaker is producing sound. Yeah? Oh yeah. 100 hertz. So let me check this. Okay. Imagine that, huh? This is 200 hertz. I don't think you will see. Oh yeah, we have movement. Two 200, 300, 400. Imagine that. 600, 800, 900. 1 kilohertz. 2 kilohertz. 3 kilohertz. 4 kilohertz. 5 kilohertz. Imagine that. 6 kilohertz. 7 kilohertz. 8 kilohertz. 9. 10 kilohertz. 11. 12 kilohertz. And still alive and rocking. Seventeen kilohertz. 18 kilohertz. 19. 20 kilohertz. And you should not hear this at 20 kilohertz, but this is a messed up speaker, so it's like don't worry about it. 21 kilohertz. This is like 25 kilohertz. You should not hear this, but this is messed up. I can hear a little bit. So let's go down again. Yeah, 1 hertz. Still alive. Imagine that. So basically this is how the speaker works. What else I can tell you? What else? Okay, I have one speaker more to test. Okay, let's test one more speaker. Yeah. Whatever. Okay, one more speaker to test. Tick, attack, tick. So yeah, in meantime, you can see this. So this is fully functional speaker. You can see it's doing his job exactly as he should. Here inside the same stuff. So let's put one hertz inside. Is it or not? 1 hertz. Let's see. See this? So this one is working as he should. Let's go up in hertz. 2 hertz. 3. 5 hertz. Come on. Basically, we have a linear movement. Electrical transfer into linear movement. Or like this. So this coil is around this one, going inside the magnet. So let's go up. much? 30 hertz. Let's go 40, 50. I can feel it. And here 100 hertz. So yeah, that's the speaker. That's the speaker. Thank you for watching. Goodbye.